Welcome back to TM Academy. Okay, let's have another problem. Okay, let's say we have vector A, which is equal to 5 centimeters going let's say south direction, and vector B is equal to 10 centimeters going west direction. Okay, so again, we will incorporate the concept of Pythagorean Theorem to find the sum of these two vectors. Okay, so graph first the given vectors. Okay, let's start with vector A, that is 5 centimeters going south. Okay, this is the vector A, and this is the vector, or with a length of 5 centimeters. Then the vector B, again, I'm going to use the polygon method. The connection is head to tail, 10 centimeter going west. Okay, so this will be our vector B with a length of 10 centimeters. Then the resultant vector is from here, from the tail of the vector A to the arrowhead of the vector B. This will be our R. Okay, take note that the vector A and vector B are perpendicular with each other, or the angle between is equal to 90 degrees. Okay, so R here again serves as the hypotenuse of the right triangle. So R, or to find the magnitude of R, we will use the Pythagorean theorem from C squared is equal to A squared plus B squared, wherein C is the hypotenuse of the right triangle and A and B are the legs of the right triangle. So on our figure, on this figure, vector A and vector B are the legs of the right triangle, and the vector R serves as the hypotenuse of the right triangle. So we have now R. R squared is equal to the vector A squared plus the vector B squared. Then we will take the square root both sides. We have R is equal to the square root of the vector A squared plus the vector B squared. Okay, plug in the values. We have R is equal to the square root of 5 centimeters quantity square plus the vector B quantity 10 cm square. Okay, so R is equal to that is 11.2 centimeter. Okay, this one is just the magnitude of R. Okay, then the theta formed by R is that is an angle from this one, from negative x-axis going to this R. This will be our theta. Okay, so properties of similar triangle to define the theta. This will be also our vector A. And this one will be the vector B. Okay, and this is our right angle. Okay, so again, we will define the relationship of this theta to the vector B and vector A. Okay, the relationship of this theta to vector A, this is the opposite side, and for vector B, this is the adjacent side. Okay, so still tangent function, that is tangent theta, is equal to the opposite over adjacent, and the value of opposite, that is the vector A, over the adjacent side, the vector B. Okay, so tangent theta, the magnitude of vector A is 5, and the magnitude of vector B is 10. Then take the arctangent both sides, that is theta is equal to the arctan of 5 cm divided by 10 centimeters. Okay, so let us calculate this one. That is arctan of 5 over 10. That is 26.6 degrees. Okay, so that theta is just the direction of the vector R. And that 26.6 is below the negative x-axis. Okay, so therefore, the resultant vector R is equal to, it is magnitude of 11.2 centimeter with a direction of 26.6 degrees. You may write this as 26.6 below negative x-axis, or you may write also the direction by 26.6 degrees south of west, since this will be the north, this is the south, this is the east, and this is the west. Or you may read also the theta from the positive x-axis, from here going to this vector. Okay, so that theta will be 180 plus, since from here this is 90 and this one is also 90, 90 plus 90, that's 180, then plus this theta, that is equal to 206.6 degrees from positive x-axis counterclockwise. Okay, so still the magnitude is 11.2 centimeters. Okay, so this is again the resultant vector. Okay, so on this figure, the length of this vector, this R, is 11.2 centimeters. Then the 26 degrees, this one, that is 26.6 degrees. Okay, reminder again, we can only use the Pythagorean theorem in finding the resultant vector if and only if the given vectors are perpendicular with each other. See you again on the next video. Thank you for watching.